Hi all. So for this next section 10.2, we're going to look at simplifying radicals. So we're going to be looking at different expressions with radicals inside and learning how to simplify them. To simplify them, there are three basic things we have to follow. There has to be no perfect squares inside the radical, and we'll show how to find that with this example. We also need to make sure that there's no radical in the denominator of a fraction, and a fraction cannot be underneath the radical sign. And we'll look at different examples over the next 2 days that show all three of these. So the first one here, the square root of 52, we are going to simplify. To simplify that, we're going to do a prime factor tree. So we're going to create a prime factor tree. So we are going to take 52, and we're going to keep breaking it down with its prime factors until it can't be broken down anymore. Now, if you're not remember our prime numbers, remember any number divided by 1 in itself. Those primes are 2, 3, 5, 7, 11, 13, 17, 19, and we could keep going, but that's about as high as we'll have to go. So for 52, we just first start and think about what are factors of 52. What are two numbers that multiply to 52? At this point, it does not matter what two factors you use. Any set of factors will get you to the same answer that are factors of 52. I'm going to start with 2 and 26. Now, 2 is one of those primes, so I'm going to circle that. 26 is not prime, so I'm going to keep breaking down 26. 26 can be broken down to 2 and 13. 2 is also prime, and 13 is also prime. So once we have all primes, every end of the tree is circled, I'm going to rewrite the square root of 52 equal to the square root of 2 times 2 times 13. And 2 times 13, 26. 26 times 2, 52. Now to finish, what we're going to do is we're going to look for what pairs of numbers do we have and move those to the outside. So when we talk about square rooting, so we're looking for those pairs of numbers, the second root. So here we have a pair of 2's. I'm going to circle that. And that pair of 2's tells us that for the square root of 52, 2 is just 2, moves to the outside, because the square root of 2 times 2 is 2, or the square root of 4 is 2. And we're left with this radical 13 on the inside. So the simplified radical 52 becomes 2 radical 13. So we do our prime factor tree. We take our primes, put them underneath the radical, and whatever we have pairs of, that goes to the outside. What we don't have pairs of stays on the inside.